Okay, lesson not 4.0, this is 2.0. We're talking about substitution and elimination. This is an Algebra 1 topic. It's basically just a review for Algebra 1. We're going to be working with 2 equations. In the upcoming lessons, we're going to move on to actually 3 equations. So starting with substitution, if you fold your foldable like I have it here, you'll have the steps over here on the right. Substitution steps. The first one is pick one of the equations and solve for x or y. So why don't we stop there and go ahead and look over at this first problem. So on the first problem, we've got 2 equations here, and with substitution, we want to pick the one that is already solved for x or y, if we can. If there's one that's not already solved for, then we want to pick the easier of the 2. So looking here, you'll notice that y has already been solved for. It's already by itself. So basically, we're good with step 1. Step 2, replace or substitute the expression you just found in for that variable in the other equation. So this is the substitution part. We know that y equals 3x minus 5. So I'm going to take that and I'm going to plug it in the other equation. So this is going to look like 8x plus y, which we know is 3x minus 5. Anytime you're plugging in, I want you to use parentheses. So whenever you're changing for the y, I want you to put that in parentheses. And that equals negative 16. So now you'll notice that we only have one variable. We only have x. So we're going to combine our like terms and solve for x. So this is the same, and so is this. 8 and 3 gives me 11x minus 5. That equals negative 16. Solving for x, we'll add 5 to both sides. When I do that, my 5's cancel. And I get 11x equals negative 16 plus 5 is negative 11. We're going to divide both sides by 11. That'll make those cancel. And I have x equals negative 11 divided by 11 is negative 1. Okay, looking over at step 3, it said solve the variable remaining in the equation. We did that. Step 4 is substitute the value for that variable into either equation. So we have x. We need to solve for y. So now that we know what x is, we can plug it in. We already have an equation for y, so we'll plug in x now. This is substituting. Y equals 3 times x. I now know that x is negative 1 minus 5. 3 times negative 1 is negative 3 minus 5. Y equals negative 3 minus 5 is negative 8. Your final solution, we write these solutions in point form. So remember, it's always x and then y, negative 1, negative 8 is the solution. Okay, let's take a look at the second example. We're going to go ahead and do another substitution problem. So remember, we want to pick one of the equations and solve for x or y, whichever one's easiest. Now, when we're doing substitution, if there is one that is already by itself, that's the equation you want to solve for. So notice in the first equation, this y is already alone. Well, I should say there's no coefficient in front of it. So we can take this equation and get y completely by itself. So we'll do 4x plus y equals 10. And we're going to solve for y because y is already alone. So all I need to do is subtract my 4x from both sides. And I have y equals negative 4x plus 10. Pick one of the equations and solve for x or y. That's step 1. Step 2 is replace or substitute the expression you just found into the other equation. So now I know what y is. I'm going to take him and plug him in right there. So we have 6x plus 2 times y, which I now know is negative 4x plus 10 equals 20. A number outside of parentheses, don't forget, that means you need to distribute. So I have 6x, 2 times negative 4x is negative 8x, 2 times 10 is positive 20, equals 20. Okay, we're going to go ahead and I'm going to do a couple of steps at one time. These need to be combined because they're like terms, and this 20 needs to move to the other side. So I'm going to go ahead and subtract that 20. The 20s cancel. 6x minus 8x is a negative 2x. 20 minus 20 is 0. Dividing both sides by negative 2, x equals 0. Now that we have one of the variables, we can plug back in to find the other one. I have an equation for y right here. That's the only variable that I don't know. So instead of my x, I can plug in 0 here. So we have y equals negative 4 times x, which we know is 0, plus 10. Now keep in mind, when you found one of the variables, you can plug into any of the above equations. Any of the equations that you've already found, you can use that to find the remaining variable. I chose this one because y is already by itself. Negative 4 times 0 is 0 plus 10. Long story short, y equals 10. Again, answers are written in point form, always x, then y. That's your final solution, the point 010. Okay, if you'll open up, there is one final problem here. I want you to try this one on your own. Pause the video and come back and see if you got it right. Okay, I'm going to start with, this time I'm going to start with your final answer. So your final answer with this problem was the point 6, negative 7. So if you came up with that answer, congratulations, you are correct. If not, let's watch and see how I work this. Now, keep in mind that you may not have worked it the same way, but you may have still gotten to the same answer, and that is okay. Substitution, we want to look for a variable that is already by itself. If you'll notice, we have x and y that are both already alone. However, the y is negative, and that'll just take a little more time to solve if I choose to get y by itself. My x is positive. That will be a little bit easier to solve for. So that means I'm going to go ahead and get x by itself, which means I need to move the y to the other side. In order to do that, I'll add y to both sides. And I get x equals, the y's cancel, 13 plus y. Here's my first equation. So now that I know what x is, I'm going to take him and plug him in right here. That looks like this. 4 times x, which is 13 plus y, plus 2y equals 10. Don't forget, you got to distribute. Four times 13 gives me 52. 4 times y is 4y. Plus 2y equals 10. Combining our like terms, this needs to be combined with this. And also, my 52 is going to have to move to the other side. I'm going to do those in one step. I'm going to go ahead and subtract my 52 That means these cancel. 4y and 2y, that gives me 6y, which equals negative 52 plus 10 is negative 42. Dividing both sides by 6, y equals negative 7. Once you have one of the variables, again, you can plug into any of the above equations that you've already found. It doesn't matter which one. Since I'm looking for x, I'm going to plug into this equation because x has already been solved for. X equals 13 plus y, which is negative 7. 13 plus negative 7 gives me positive 6. Again, bringing me back to my final answer of 6, negative 7. Okay, let's move over to the word problem for substitution. It says an adult ticket, so X's are the adult tickets, to a museum costs 3 more than a children's ticket. When 200 adult tickets, I think we're going to need a different color, 200 adult tickets and 100 children tickets are sold, the total revenue is $2,100. Write a system of equations. Usually with this, you can go on the basis that each sentence will have its own equation. And remember, we're working with two system equations, so likely this is going to have two different equations. An adult ticket, X. So the adult ticket costs 3 more than a children's ticket. The adult ticket equals, it costs 3 more than a children's ticket, which they're calling Y. 3 more than a children's ticket. There's your first equation. The second equation, when 200 adult tickets and 100 children tickets are sold, the total revenue is $2,100. 200 adult tickets, so 200 times however much an adult ticket costs, plus 100 times however much a children's ticket costs. When we add those together, the total revenue is $2,100. There's your second equation. What is the cost of each ticket? I want you to pause the video and solve this system of equations. Come back and see if you've got it correct. Okay, again with substitution, if one of the variables is already solved for, you've already won half of the battle. We need to take this and substitute it in here. So that looks like this. 200 times X, which we know is 3 plus Y, plus 100 Y equals 2,100. Distributing. 200 times 3, that gives me 600. 200 times Y is 200Y plus 100Y equals 2,100. Okay, combining like terms. Our y's need to be combined, and also my 600 needs to move over. I'm going to do that in one step. Subtract 600 from both sides. Those cancel. 200 plus 100 gives me 300y equals 2,100 minus 600 is 1,800. Divide both sides by 300, y equals 6. Now that I know y, I can plug that back into the x equation to find x. So x equals 3 plus y, which is 6. X equals 9. All right, there is your substitution. If you have any questions or confusion, please go back and look at the substitution portion. And we're going to move on to the next one, which is elimination. So we're going to close this back up so we can look at steps for elimination. Maybe, if it'll stay closed. Okay, substituting. We literally substituted one equation into the other. With elimination, we're going to try to cancel out one of the equations or one of the variables. Step 1, write the equation in standard form. If you didn't remember, this is standard form. AX plus BY is equal to C. Multiply one or both equations to make opposite terms. Let's take a look at what that might look like. Open your first equation here. Elimination. We are wanting to eliminate a variable. So what we're going to be looking for is, when we look at these two equations, if we were to add them together, would anything cancel automatically? So if we were to add these two equations together, hopefully you'd see that the 3y and the negative 3y would cancel. That is elimination. On your steps, that's what we're talking about when we talk about opposite terms. One's positive and one is negative, so that when we add them, they would cancel. We are literally going to add these two together. So we've got 5x minus 8x is negative 3x. The y is canceled. Negative 19. This is a typo, you guys. This is supposed to say negative 14. Negative 19 minus 14 is negative 33. Divide both sides by negative 3. X equals positive 11. Okay, so multiply one or more equations to make opposite terms. We didn't need to do that because the terms were already opposite. Step 3 says add the two equations to eliminate x or y, which is what we did. Solve for the remaining variable. We did. We solved for x. Step 5 is substitute the value into either equation. So just like we did before, once you know one of these, you can just plug back into either of the equations to find the other variable. So we already know x, doesn't matter who you plug back into. Here's what I notice. This y is negative. This one's positive. Positive numbers are always more easy. My English. They're always better or easier to deal with than negative ones. So I'm going to choose to plug back into the first equation. 5 times x, which is 11, plus 3y equals negative 19. And from here, we just get y by itself. 5 times 11 gives me 55, plus 3y equals negative 19. We'll subtract 55 from both sides. That gives me 3y equals negative 19 minus 55 is negative 74. Divide both sides by 3. My 3's on the left cancel. Y equals negative 74 divided by 3 does not go perfectly. It stays a fraction. If you put this in your calculator, you're going to get a decimal. We like to leave things in fraction form, so I'm going to leave this as y equals negative 74 over 3. Now remember, we write our final answers in point form. So we have x, which is 11, and y, which is negative 74 over 3. All right, let's take a look at the second one. Write the equations in standard form. Okay, it looks like we're already there. X, y, and c, x, y, and c. Multiply one or both of the equations to make opposite terms. So remember, we're trying to eliminate something easily. So we want to look at these two equations and see if there's already something that will eliminate right off the bat. I don't see anything that will eliminate. I do see 2y and 2y. However, they're both positive. If I want them to eliminate, one of them is going to have to be negative. So what I'm going to do is I can multiply one or both of the equations to make opposite terms. So I'm going to take this equation and I'm going to multiply it times -1, the whole equation. -1 times -x gives me positive x. -1 times 2y is -2y. -1 times 21, -21. I'm just going to rewrite this top equation down here because I want it to stay the same. Now, add the two equations to eliminate either x or y. So we're going to add these together. Now you'll notice that I have -2y and positive 2y. So just like that, they cancel. And now I'm down to only one variable. 7x and x gives me 8x equals -21 and -19 is -40. If I divide both sides by 8, x equals -5. Plugging this back into either of the above equations, it does not matter which one you'd like to plug into. I know x, I'm just going to plug it in here. No, I don't really have a reason for that, it doesn't matter. Negative times x, which is -5, plus 2y equals 21. Negative times -5 gives me positive 5 plus 2y equals 21. Solving for y, I'll subtract my 5 from both sides. These cancel. I get 2y equals 21 minus 5 is 16. Dividing both sides by 2, y equals 8. Final answer, -5, positive 8. Okay, I want you to take a minute and do the last one on your own. Keep in mind that you can multiply both equations by whatever you need to eliminate a variable. So pause this video and come back and see if you got it right. Okay, I'm going to start with the solution on this. Your solution would have been 8 and 4. 8 and 4. So if you came up with that answer, congratulations, you got it right. If not, take a look at how I've worked this problem. Remember, our goal is to multiply one or both of these equations so that we can eliminate the x and eliminate the y. Right now, neither one of them are going to eliminate, and they don't add up nicely like this did. So what we can do is think of common factors. So 3 and 4, I guess I should say common multiples. 3 and 4 can come together to make 12. So if you'll notice with the y's, one is already positive and one is already negative. That is a good thing. I can multiply this entire top one by 4 because that will make this positive 12. And if I multiply the entire bottom one by 3, this guy will become negative 12, and these will cancel. Keep in mind that when you multiply, you have to multiply the whole equation by the number that you've chosen. So 4 times 5 gives me 20x. 4 times 3 gives me 12y. 4 times 52 is 208. Same thing with the bottom equation. 3 times 9 gives me 27x. 3 times -4y, -12y. 3 times 56, 168. Step 2 is to add these guys together. And this is what we wanted. 12y and negative 12y cancel, so we have eliminated that variable. 20 and 27 give me 47x equals 208 plus 168, 376. Again, use your calculators to figure this out. Divide both sides by 47, x equals 8. We're going to take that x equals 8 and plug it into either of the original equations. It does not matter which one. I'm going to go with the top one. 5 times x, which is 8, plus 3y equals 52. 5 times 8 gives me 40, plus 3y equals 52. We'll subtract our 40 from both sides. Forties cancel. I get 3y equals 52 minus 40, which is 12. Divide both sides by 3, y equals 4. And again, your final answer, 8 and 4. Okay, the last one, down to the word problem. The cost of a blanket is X dollars, and the cost of each embroidered letter is Y dollars. Your name has 6 letters, and the total cost is $29. Your name has 6 letters, and the total cost is $29. Your friend's name has 3 letters, and the total cost is $24.50. Write a system of equations. Pause this video and see if you can write 2 equations that go along with these sentences. We're going to have to pay for the blanket, so 1 blanket, plus the cost of each embroidered letter, which is Y. It says my name has 6 letters, so I've got 6 letters times however much it costs per letter. And all of this added up gives me $29. That's for me. My friend, on the other hand, she also has to buy a blanket. And she's going to have to pay for each of her letters, but she only has three letters in her name. So 3 times Y. Her cost is $24.50. There's your system of equations. What is the cost of the blanket and the cost of each embroidered letter? They're asking you to find X, which is the cost of the blanket, and they're asking you to find Y, the cost of each embroidered letter. Basically, they're asking you to solve this system of equations. Now, we can use substitution or we can use elimination. However, keep in mind with elimination, what you're looking for is something that we can cross out fairly easy. With substitution, you're looking for an equation that maybe has already been solved for, meaning it only has one variable that's been solved for already. So when you look at these 2 things, I hope that you'll see that we have an X and an X here. If we make one of these variables, one of these equations negative, the X's will cancel. So even though we can use substitution, it would probably be easier for us to use elimination to solve this. So I'm going to keep, it doesn't matter which one we make negative, I'm going to keep the first one the same. X plus 6y equals 29. And the next one is the one I'm going to multiply by a negative. So if I multiply negative 1 times x is going to be negative x. Negative times positive 3y is negative 3y. Negative times 24 is negative 24.50. Adding these guys together, your x's cancel. 6y minus 3y is 3y. 29 minus 24.50 is 4.50. Divide both sides by 3. Y equals $1.50. The cost of each embroidered letter is $1.50. I do need to figure out how much the cost of the blanket is. So now that I know this guy, I'm going to plug it into one of the original equations to find x. Doesn't matter which one, we'll just go with the top one. So x plus 6 times y equals 29. 6 times 150 is 9. Getting x by itself, we'll subtract 9 from both sides. The 9's cancel. And I get x equals 29 minus 9 is 20 bucks. The cost of the blanket is $20, and the cost of each letter is $1.50. This concludes substitution and elimination with 2 equations. If you have any questions, make sure you go back and review the video.